So I'm going to offer a few reflections on the second half of Bjørn Ekeberg's book, Metaphysical Experiments. And I want to frame this discussion in the context of the history of cosmology as a discipline, so in the modern period, at least. And I think a lot here pivots on Immanuel Kant and his critique of pure reason, where he engages in a transcendental critique of the idea of cosmology as a kind of science which could give us knowledge of the cosmos as a whole. And, Kant points out that based on what we can observe in our experience, what's given empirically, there's a sort of antithesis generated by reason in asking certain questions about the cosmos as a whole. Is it eternal or created, for example? Is space infinite or finite? These sorts of questions can be argued rationally on either side, right? And so we can arrive at contradictory answers without having made any logical mistakes based on the same given empirical data. And, this is Kant's antinomies or antinomies. And he shows how, reason and understanding and natural science are limited in their ability to know anything definitively or determinatively about the cosmos as a whole, right? And so the cosmos becomes this sort of big idea that Kant says is off limits. We have not the empirical reach or the conceptual acuity to know anything about the universe as a whole, right? And so if we do cosmology, for Kant, it's purely speculative. But what's interesting is that much earlier in his career, before Kant began constructing this critical method to tear down the old dogmatic approach to metaphysics, he had written in 1755 a text called Universal History and Theory of the Heavens. And it's one of the earliest accounts of cosmogenesis that we have. Descartes has his own kind of version of this developmental conception of the universe. But Kant, in addition to, articulating the kind of nebular hypothesis of the formation of the solar system and so on, also suggests that these nebula that astronomers had already been able to see back in the 18th century with telescopes, these, kind of blurry patches outside the ecliptic of our Milky Way, Kant suggests that these are actually other Milky Ways, he says, right? He doesn't use the word galaxy yet, but he's already speculating that we live in a much larger universe, not only of other solar systems, but of other Milky Ways, right? Galactic systems, as we would call them today. And what's also interesting here is that despite Descartes, in his attempt to mathematize nature, lost out to Galileo, right, and his more metalogical approach, Descartes wanted to maintain some autological givenness and connection to the physical in his approach to mathematizing nature. And I'm going to go into these distinctions: metalogical, autological, analogical, hypological, that Ekeberg makes. You might have found it a bit hard to track, but it's really important to get at least a sense of what these modes of thought mean. They're not logics in an analytic sense, they're more like modes of thought. And when we engage in science and metaphysics, we're always drawing on aspects of each of these, but we'll get more into that. But the point is that what's interesting about Descartes is that he was imagining nature as full of vortexes, and that the best way to study the movement of extended matter through space was in terms of fluid dynamics. And that, for Descartes, nature was a plenum, not a void. or space was a plenum, not a void, right? There's no such thing as empty space in Descartes' cosmology. And I think Descartes has in some sense been redeemed a bit by the proliferation nowadays of field theories, and even already with electromagnetic theory that Maxwell articulates in the 19th century. You have this sense of nature as full of lines of force, right, of activity, of energetic transmission. And Whitehead's very much in alignment with this Cartesian view. And when we do look out at the cosmos and see these spiral galaxies everywhere, it's like Descartes' vision starts to become a bit more credible, right? Even though mathematical physics went the way of Galileo into this metalogical space. And so this is all the kind of history of the context of cosmology as we know it nowadays in the 21st century, after what Ekeberg calls the 20th century metalogical turn. It's a metalogical turn in the sense that it's leaving behind the autological grounding in actual experience, in the givenness of the physics of forces and gravity and light and so on, and a movement into a more abstract domain of model making, and gradually, coming to have only a very tenuous connection to actual measurable, observable factors. And so let's get into these different logics or modes of thought, right? So when Ekeberg is talking about autological thinking, I mean, we have to think about these logics as like modes of metaphysical inquiry, right? And to the extent that there's always a metaphysical background to science, scientists are engaging in some forms of autologic, some forms of metalogic, and some forms of hypologic. So even in the 20th century with quantum physics and relativistic physics and the increasing distance of the mathematical models from our sensory perceptions and our bodily feelings, there's still a degree to which, science is grounded in observations, right? But the problem with contemporary cosmology, as we've seen, as Ekeberg treats it, is that it's grown too distant from our embodied experience, from the phenomenological life world, and we need to, remake a bridge between these domains. But when we think of the autological, this is a connection to something causal that's not abstract, it's directly given in our experience. It's, whether that's a gravitational force or the radiant energy of light that we experience as heat. There's something tangible at the root of autological thinking. And it's a sense of direct intuitive connection to that which we are thinking about. And so autologic is a mode of thought really engaged with perception and experience and something given. Whereas metalogical thought is more like thinking about thinking and only has a kind of tenuous connection to the perceptual world. Of course, when we're thinking about the relationship between thinking and perception, between thought and sensation, we also need to find a place for nature, right? That's the object that science says that it's studying and trying to know something about. When you're engaged in metalogic, you're more engaged in a kind of mathematical exercise, searching for internal consistency and coherence in your model. And yeah, every once in a while you're checking in with the observable world to make sure that your free parameters are properly adjusted. But at the end of the day, you're really focused on the unity of your model. Whereas when we do when we do autologic, we're touching ground again to connect with how we directly encounter the world in our experience. And so we're looking for practical application, but we're also looking for direct observation, right? And so somehow we need to be able to coordinate between this metalogical domain of mathematical ideas and relations between the model. We need to coordinate that with the with our perceptual experience of being in vibratory resonance with other beings in our environment. And somehow our conception of nature has to be adjusted on the basis of the coordination between these two domains of concrete feeling and abstract thought. So don't think of these different modes of thought as like there's a good guy and a bad guy. We need them all. It's just a matter of how to coordinate them. I haven't talked about the analogical and the hypothetical or hypological yet. Analogy is really important in science, right? In some sense, when particle physicists engage in research at the Large Hadron Collider, they're doing this work on the basis of an analogy between the universe as a whole, and indeed the origins of the universe as a whole, and this particle accelerator. They're saying that this particle accelerator is analogous to the universe as a whole because it can produce particle collisions at super high energies. They can simulate the Big Bang. That's the idea. So there's an analogy at work at the root of even the hardest of the sciences. To think that you could do science without analogy and metaphor and so on is silly, right? And so I think this shows how there's still a poetry to science. Hypologic then is just, normal hypothesis making, but Ekeberg really wants to dwell on the way in which, in the 20th century, kind of spurred on and encouraged by metalogical reasoning, hypological reasoning became increasingly detached from the experiential given, right, the autological. And he talks about Einstein's definition of light, of the speed of light, as a constant, right? This wasn't a discovery. When you actually measure light, even in a vacuum, it's very difficult to get the same, to clock it at the same speed. Light always is moving through some kind of medium, right, first of all. And so to say that the speed of light is a constant is not an empirical fact. It's not a discovery. It's not an observation. It's a definition. It's a kind of postulate. And on that basis, Einstein is able to kind of reinvent a rigid ruler or a standard clock for the purposes of measuring relativistic space-time, right? It's so that the constancy of the speed of light becomes Einstein's new measuring device, but it is a device, right? It's a hypothetical, as if we say the speed of light is a constant, then we can make these kinds of measurements of the way that space and time warp because of energetic and mass changes. So Ekeberg also talks a little bit about the debate between Bergson and Einstein, and we'll return to this in a later module. But for now, it's important to recognize that after this point, Bergson and his whole attempt to bring together and integrate metaphysics and science, that whole project just gets increasingly dismissed and rejected. And, as Ekeberg says, Einstein basically declares metaphysical independence for science from philosophy. And Bergson and his whole approach to creative evolution and the importance of our intuitions of the duration at the heart of things, this all gets dismissed as kind of anti-intellectual and anti-science. And Whitehead says in the beginning of his book, Process and Reality, that he's really in this effort at an organic philosophy trying to save the point of view of Bergson, and he also mentions William James, from the charge of anti-intellectualism, right? And so to do this, Whitehead has to make some important adjustments and amendments, metaphysical amendments to some of Bergson's doctrines, but he still wants to preserve the sense that abstract science and abstract thought and this kind of metalogical and hypothetical thinking does damage to our experience and does damage really to our knowledge of nature if it does not remember that all of its intellectualizations are rooted in sensory motor cycles, right, and perception action loops and embodied experience. And Whitehead certainly agrees with Bergson about this critique, and his only change to what Bergson says is to not say that that it's only the mind or the intellect or this drive towards scientific abstraction that creates atoms, right, in nature or individuals in nature. Whitehead wants to not just say that everything is continuous. There is an element of continuity in nature, but Whitehead's also a kind of atomist, right? And so while Bergson will say that, an atom as a real individual is only exists for the mind which isolates it, Whitehead gives his atoms each their own mind, their own mental pole, he would say, and it's the mental pole that unifies Whitehead's atoms. Now, when I refer to Whitehead's atomism, I'm talking about a dynamic process relational atomism here. We're not talking about little tiny billiard balls anymore, or point instants, as we might in a mechanical philosophy of nature. Whitehead's atoms are actually events, or what he calls occasions of experience in his mature metaphysics. And so there's both a physical and a mental phase to Whitehead's actual occasions of experience, right, to his atoms or drops of experience. But he does want to say that, mind, mentality, even abstraction is something that's going on in nature, in all of the organisms, in their relations with one another, in the non-human universe. And it's not the human being or the modern Western scientist that invents abstraction. And so, Whitehead is accepting Bergson's critique of the way that the intellect tends to spatialize nature. But he's also suggesting that when we engage in scientific inquiry, we're not just creating Whitehead wants to say when we do science, we're not just taking flight from actual experience into a world of abstract mathematical ideas, unlike Max Planck, who said, and I quote, and Ekeberg quotes him, "The increasing distance of the physical world picture," Planck says, "from the world of the senses means nothing but a progressive approach to the real world." In contrast to Planck, Whitehead would say that the divergence of formula about nature from the appearance of nature has robbed the formula of any explanatory character. Right? Whitehead says that in Modes of Thought, which we'll read very soon here, page 154. And so you can see how Whitehead is refusing this bifurcated view of nature, which would treat only the mathematizable elements as the real elements, which exist in sort of they exist in a disjunction with the world of perception of nature as we actually experience it. Whitehead wants to connect our abstractions back up with our experience and, give the equations of physics flesh and blood, and to recognize that the transmission of energy is a kind of pulsation of emotion. This is an analogy that Whitehead will try to construct in his speculative philosophy. So, as Ekeberg points out, Bergson's whole attempt at a synthesis between metaphysics and science was really geared more towards this electromagnetic philosophy, focused on the continuity of the ether and so on, a kind of 19th century science. And in the early 20th century, it was relativity, but also quantum theory that kind of brought a different approach back into play. Relativistic physics is still about a continuous manifold, but quantum theory brings in the discontinuous in a big way. And Bergson's existing metaphysics at that point wasn't quite prepared for this development in science. And Whitehead, in a way, is picking up the effort that Bergson began after quantum and relativistic physics emerge on the scene. Whitehead was also, he studied with one of Clerk Maxwell's students, and so Whitehead's one removed from Maxwell himself in terms of learning the mathematics of electromagnetic theory. So Whitehead understands continuity quite well, but he also has this atomism, as I was saying, right? That he wants to be able to say that nature also has concrete individuals, and that indeed, if we're talking about concreteness, we're always talking about individualities, right? Actual occasions of experience with some sense of completeness and some autological givenness. That, in other words, not just that they're given, but that they're also self-creating. They're self-giving, if you want. So one thing I'll say also, though, about how Bergson and Whitehead really are convergent is in Whitehead and Bergson's accounts of perception. Bergson's basically saying that our perception is a kind of virtual action in our bodies, and he develops this optical metaphor of light hitting a medium, the medium of a body, and either being reflected or being absorbed. And he suggests that sense perception is kind of like measuring the reflective power of our bodies, while the feeling power of the affective power of our body is more about how we absorb light, right? So affection is absorbing this light, and perception is reflecting the light. And this is really quite close to Whitehead's account of perception in terms of these two pure modes of perception that he calls presentational immediacy, which is more like sense perception, and causal efficacy, perception in the mode of causal efficacy, which is more like bodily affect, this absorptive aspect of perception that Bergson is describing. And this distinction they're called pure modes of perception because, this is a kind of idealization. In concrete experience, they always occur kind of mixed up together in what Whitehead calls the mode of symbolic reference, where we're connecting up what is presented to our senses in the immediacy of the present in a kind of spatially projected array. We connect that up with the causal efficacy of these sort of vague influence of the causal vectors of the past as they're transmitted through the world into our bodies and through the nervous systems of our bodies to the presiding occasion of experience that's integrating this perception action, these perception action cycles. And so Whitehead and Bergson here are both trying to put the human being back into the context of its affective and perceptual life, and to remind us that, the abstractions and the models that we build, the theories that we concoct, are in some ways derivative from and responsible to this perceptual, this experiential gestalt. And whatever physics is, it's going to, at the end of the day, be an attempt to describe and elucidate and maybe in some cases explain concrete experience, but not by replacing it with abstractions. If we're going to explain something, it's always going to be in terms of its concreteness, not in terms of an abstract model behind the scenes that we can't experience, that's supposedly responsible for producing experience, right? That would be to revert to a kind of dogmatic metaphysics out of touch with what the scientific method really should be all about. So Ekeberg, wraps up his book by talking about the irony of our moment in the history of science and technoscience, really, when just as we have the ability to build these amazing instruments, space telescopes, to rocket into space and put into orbit, at this same moment, we're losing the ability to see the night sky ourselves from our vantage down here on Earth because of light pollution. How many of us can actually see the Milky Way in our backyard? On a really dark night, I can barely see it where I am. It's there, it's faint. But for most people in the developed and developing worlds, it's becoming increasingly difficult to have a direct relationship with the cosmos. More and more, our relationship is to these abstractions. And, the point of this whole text here is to critique a kind of, what we could call the cosmology industrial complex, which has become locked into a particular model because of for non-scientific reasons, right? For reasons of the professional institutions of science, and for reasons of the necessities of political funding and public support for that funding. It creates this kind of this industrial complex. And to actually the point here is to save scientific inquiry from the kind of capture that can occur by these institutional and social forces. And at the end of the day, what we're really seeking is not this kind of objective truth that, say, authority, a state or corporate authority could then use to manipulate a population, which is what, statistical science has largely been about for the last several centuries. Rather than searching for a kind of objective truth to master nature, what Ekeberg and Stengers, as we'll see, and both, Stengers and Latour at least drawing on Whitehead and being very influential on Ekeberg. So Ekeberg's getting Whitehead kind of secondhand there. They're seeking relevance in our scientific inquiries rather than something called objective truth. And this pursuit of relevance is really an attempt to situate knowledge, again, in the communities to whom it matters, to whom it matters what nature is and what we do to nature, to whom it matters what we are as human beings and what we do to each other, or what a state or corporate power does to us, right? And so it's seeking relevance rather than the power that would come from wielding the objective truth.